A substance with high energy electrons is a good electron donor, while one with low energy unfilled orbitals is a good electron acceptor. When a good donor encounters a good acceptor, the high energy electrons on the donor transfer into the lower energy unfilled orbitals of the acceptor. The electron transfer reaction can be broken down into two half reactions. The first is called oxidation. Oxidation is the loss of electrons. X loses 2 electrons, so it undergoes a 2-electron oxidation. Note that the loss of negative charge increases the oxidation state of the donor. In this case, the loss of 2 electrons increases the oxidation state of X from 0 to +2. The second process is called reduction. Reduction is the gain of electrons. Y gains 2 electrons, so it undergoes a 2-electron reduction. The gain of negative charge during reduction causes a reduction in the oxidation state. In this example, the 2-electron reduction causes a reduction in the oxidation state of Y from 0 to -2. Note that electrons appear in half reactions, but the number gained during reduction always equals the number lost during the oxidation. So the electrons do not appear in the net chemical equation. Oil rig is a common mnemonic used to remember the difference between oxidation and reduction. Oxidation is loss of electrons, and reduction is the gain of electrons. A substance cannot be an acceptor in the absence of a donor, so electron transfer requires both reduction and oxidation. Consequently, this broad class of chemical reactions is often called redox reactions. In the absence of an acceptor, the electrons would remain on the donor. Thus, it is the presence of the acceptor that causes the oxidation of the donor. That is, the acceptor oxidizes the donor. Similarly, the donor reduces the acceptor. Therefore, the donor is said to be a reductant or reducing agent because it has electrons that it can push onto an acceptor and reduce it. Similarly, the acceptor is called an oxidant or oxidizing agent because its low energy orbitals can pull electrons from a donor and oxidize it. In summary, a redox reaction involves an electron transfer from a donor to an acceptor. The donor loses its electrons, is oxidized during the process, and is the reductant. The acceptor gains electrons, is reduced by the electron transfer, and is the oxidant. Consider the redox reaction between iron and copper 2+ ions to produce iron 2+ ions and metallic copper. 2 electrons are transferred from iron to copper 2+. So iron undergoes a 2-electron oxidation, and copper 2+ undergoes a 2-electron reduction. Iron reduces copper 2+ and is the reductant, while copper 2+ oxidizes the iron and is the oxidant. After the acceptor has gained electrons, it loses its low energy unfilled orbitals and gains some higher energy electrons. That is, the oxidant in the reaction, designated OX1, is converted into a reductant, designated Red1. Similarly, the loss of high-energy electrons also creates an unfilled orbital at lower energy on the donor, so the reductant, Red2, is converted into an oxidant, OX2. An oxidant and the reductant it becomes are called a redox couple. Thus, OX1, Red1 form a redox couple, and OX2, Red2 form a redox couple. Redox reactions then involve only 2 redox couples and are often abbreviated as OX1 plus Red2 goes to Red 1 plus Ox 2. Applying this terminology to the reaction between copper 2 plus and iron, we establish the two couples as the Cu2 plus Cu couple and the Fe2 plus Fe couple. The oxidant in the reaction is copper 2 plus, so it is Ox 1. Ox 1 is converted into Red 1, which is the other half of the couple, or Cu. The reductant is Red 2, which is iron, and it is converted into the other half of its couple, Ox 2, which is the iron 2 plus ion.